So hello, my name is Professor Serena Cussen. I am the Head of Department of Materials Science and Engineering at the University of Sheffield, and I run the UK's Faraday Institution project on next generation cathodes for lithium-ion batteries called FutureCat. So a lot of my research is focused on new synthetic routes to energy storage materials, particularly for battery applications, whether that's lithium-ion batteries, sodium-ion batteries, or solid-state batteries. And a lot of what I'm interested in is trying to make better materials in a better way. So I'd like to try to develop synthetic routes that have less energy demands, but also deliver those materials that have those expected performance KPIs that one would want from a particular battery material. Material science and engineering is like the perfect subject to be in to start to try to unpick some of these challenges that face battery materials, because it sits, at the interface of chemistry, physics, engineering, mathematics. And so we can start to understand, the fundamental challenges that need to be overcome to deliver battery materials of the future. So once we've identified a synthetic route that we think looks promising, and it's given us a material that has some performance characteristics that would be indicative of great promise, we would head along to the ICIS neutron and muon facility to try to understand, well, what is the structure of that material? And looking at things like the actual performance of these materials, we make great use of the muon facilities available at ICIS. And then all of that information that we glean from these really state-of-the-art experiments that we do at central facilities, it then all feeds back into our design process. What have we learned from those structural and dynamic characterizations, and how do we use that then to make even better materials for the future? So if we want to design and discover and then deploy new materials for energy storage, there is no one group or one person that's going to be able to do that on their own. And that's one of the things that I love so much about working in this area. It's highly collaborative. And so particularly in the work that I do at the Faraday Institution on next generation cathodes, it's a number of universities across the UK, a number of partners across the UK, including the ICIS neutron and muon facility, who all come together and share that expertise and knowledge so that we're able to help each other find that path to the next material that we want to be able to study. So that collaborative nature, I can't imagine doing this job without that. And you could even think about it from the next level up. If you're thinking about, well, what does net zero look like? What is the energy landscape of the future? Again, there won't be any one silver bullet that can tackle every need that we have as a society. And so what really excites me is what that landscape will look like. It will be a combination, a hybrid of very many different energy storage and conversion techniques and tools and devices. And batteries will form part of that. And so it's really exciting to be working on something which will have real impact in the near future and will form part of that fabric of what society looks like in a net zero future.